And so the context again of what we're doing is that continuous delivery is kind of made up of two main pieces. There's kind of one piece is all about keeping your software in a state where at any point you could deliver it. So you're not necessarily doing something like continuous deployment and like delivering every commit, but you could if you want, because you're confident that your software is in good shape. And then the other piece is about making it really easy to do that delivery. So what we're focusing on today is the first bit, which is all about making sure that this stays in a good state. Right now it's in a good state, it works, test pass, but there's no automation, so it's actually pretty easy to get this into a bad state. And this is also what people refer to as continuous integration, which is continuously integrating changes and verifying that they actually work, which is kind of sometimes the missing piece. So I have a pull request, a branch that has a change in it that I'm going to merge. Let's say I'm working on this service, beautiful cat coin service, and I'm going to make a change where, because this cat coin is just totally hard coded, I'm going to change it so that the value it returns for cat coin is 2.5 instead of 2. So pretty exciting. But as you can probably tell, or you can guess, the tests aren't being updated here. So let's say that I create this pull request. Everything seems good. I put a really descriptive message in here. I get a review. The test is, hold on a second. What is happening? Why is it already running a check? Well, this is an adventure. One moment. But I thought that I deleted everything that had the automation in it. So why are you? What? Okay, let's try that again. Maybe did I like accidentally reopen one of the existing pull requests? Well, it's not as bad as having a demo that doesn't work on a live stage, so that's pretty good. No, I think that was a brand new. Okay, one more time. Now everybody's also going to learn that I am not very familiar with GitHub Actions at all. Why? I wonder if it's because of the configuration of the repo. I actually don't use GitHub Actions very often. If you know me, you would know I actually work on a project called Tecton, which is this project with this beautiful robot cat. Yeah, we're more familiar with Tecton. But anyways, I have a theory that I have set the repo into a weird state here. I have no branch protection rules. I mean, it hasn't even run the workflow, so how could it possibly know that it has failed? What? This is from, I guess it's because the commit is the same, and I ran this yesterday when I was trying this out, so it seems to be just remembering that, which I really wasn't expecting. But okay, so let's do this differently. I'm going to just make a brand new pull request. Put this change in it instead. Okay, so that's probably more fun to watch anyway than we can pull requests. I hope a couple of the other ones work because they're a little bit harder to produce. Anyway, so get rates, cat coin hub. So I'm pretty sure that was just changing. Just going to change those two. That's what I did, right? Yeah, 2.5. Okay, so let's just start over. Let's say I change those. We'll create a new branch. Doing force push, that's a bad habit. Thank you. All right, brand new branch, brand new PR, no automation. Aha, okay. All right, so rewinding. We don't have any automation on this repo, except for the stuff I was playing with last night to try to make this go smoother. Probably be better off starting from scratch. There's no automation. There's a change here that seems pretty innocuous. I mean, if you're in the habit of using unit tests, you would probably right off the bat be like, where's the corresponding test for this? But let's say that we didn't know that. So we merge this, and then, oops. So what's happened now is that we don't realize it, but our repo is actually in a bad state. Our software is now in a bad state. So if we were to, so this is a pretty innocuous change, but you can imagine some other change going in that breaks a bunch of tests that actually results in bugs and failures. And we would not feel, we shouldn't feel safe deploying this in its current state because we don't actually know what state it's in. So if I run the unit tests, for example, so here the tests fail right away because there is a problem. But again, with no automation, we really don't know. And that's the kind of thing that leads to people being nervous about doing deployments or about doing releases because you really don't know what state this is in. So you want to be careful and you want to do some kind of testing period or something to make sure that it's fine before you actually do the deployment. So what can we do? So let's back that change out. And so I'm going to do it the bad way, which is to once again reset to this. I feel like something terrible is going to happen while I'm doing this because I'm force pushing main. I'm probably going to stop paying attention for a second and force push completely the wrong thing, but so far so good. Okay, so back before our change, back to a state where our test will pass. So then let's say that we actually add, we can add some automation to run our tests. So I'm going to add GitHub action that is going to run our Python unit tests. And I'm going to try to do it with this pre-existing branch that I made. But so just an overview. This is going to be run on every pull request, and you can look it up. There's default, there's different states a pull request can be in that you can specify which you want to run on with GitHub Actions. In this case, I think this defaults to, I want to say, open, synchronize, and reopen. Yeah. But there's some other states as well, which we'll actually see later if we get to it. So this is going to run the tests. It's going to use an action to check out the code. It's going to install Python. It's going to install any dependencies if they're relevant, which they aren't to these tests, but it doesn't matter, and then it runs the unit tests. So getting this to run is going to be as easy, knock on wood, as opening a little PR that hopefully doesn't, I don't think we'll actually run into any trouble with this one because it's not like we expect this to fail. So opening a PR to add this GitHub action configuration in the location that GitHub expects. And this is why I think if anyone was trying to go from no automation to some automation and they happen to be using GitHub, I would certainly recommend using GitHub Actions. I mean, why not? It's right there. I think once you start, you need to do more complicated things or having more complex requirements on what you need to do, then you could start reaching for something like the project I work on, Tecton, especially if you're using Kubernetes, because Tecton is Kubernetes based. But if you're especially not using Kubernetes and have no reason to start at the moment, then something like this will work just fine. So let's see, we're gonna, merge in our workflow. And you probably saw GitHub actually detects that it's there and runs the workflow as part of the pull request, so we can make sure it works before we two checks have passed. Why are there 2 checks? I gotta put this repo in some kind of a good state. Let's see. Oh, there's not 2 checks. There's 1 check. There it is. There it ran. So installed everything, ran the tests. Our 1 test passed. Hooray. Okay, so then just to complete the circle, what happens with our other pull requests? Let's say that the one that we tried to merge before that put our repo into a bad state. If we were to try the same thing now, then hopefully it doesn't matter if it remembers or not, because it should rerun them anyway, I think, even though it's a different commit. So there we go. Okay, so it's running the test again. And now we should be stopped from merging this because it actually fails the test. So this would prevent us from getting the repo into a bad state in most cases. And this is kind of where, this is a great place to start. And this is also where a lot of people would stop because they now have automation to run their tests on the pull request. And they feel like as long as that passes, they're good. Let's see. So yeah, so ran the test, failed, stopped the PR from going in. Excellent. Okay, so have we covered everything? It turns out that it's actually still possible to get some changes in, even if the bugs that they cause are covered by tests that fail when we have PR-based triggering like this. So what I'm going to show you is two separate changes, which we might have to create new branches for, but we'll see. Which they do something, they're touching some similar code, but they're doing something slightly different. This is a little bit contrived. Well, okay, I'll get into that in a second. Okay, so let's say the function that gets daily rates, it by default, if you don't give it a time period, it will default to this max period. So for some reason, this one engineer comes along and wants to change the default from max to 7. So if you don't provide anything, then we're going to actually just provide the last 7 days. And so they make that change, and then they also add a test for it. I mean, it seems like everything's being done right so far. They've got a test to cover it. A little bit weird that there wasn't a test for that before, but we'll put that aside. However, imagine that at the same time, there's another engineer who is also trying to change this logic, but they wanted to default to 30 days instead of 7 days. And they've done it in a very bizarre way, which is definitely concocted just to make this example work, where instead of changing the default in the actual function signature, they've changed it somewhere else. Terrible idea. Hopefully they wouldn't do this, number one. Hopefully someone reviewing this would ask about why it's being done this way, where there's this default being specified in 2 different ways. But anyways, the point here is that they're actually changing 2 different lines of this same function. And that's where the problem is going to come in. And then they also add a test, but they just so happen to add that test after the one that was already there, and the other PR will add it before. So these are actually, both PRs are going to change different lines, which means that the normal way that we catch conflicts is that we rely on these version control systems to be able to tell that the same line has changed. But in this case, we can't rely on that because it's actually different lines that are changing. And again, this is pretty contrived. But if you start thinking about different engineers making changes to different files or to different packages or libraries and then merging those together, that's a much more, I would say, realistic scenario to encounter, where you're depending on a library and someone else changes that library and then those changes happen to go in at the same time. So let me show you specifically what can happen here. So let's say the person who's trying to change the default to 7 opens a pull request. So they're making their change, default is 7, pull request, and so immediately won't quite know what's going on there. Immediately the automation will kick in and we'll run the unit test, and they added a new test, and that test is going to pass, and the previous test was already there is also going to pass. But at the same time, this other person is going to open a pull request to make their change, to change the default to 30. So we have these 2 pull requests happening at the same time. First default. I don't have branch protection on, which I will show you later. So I need to demonstrate this. Okay, so on the first pull request, the checks passed. We ran the unit tests. We have 2 tests now. They both passed. Great. So the thing is that the way that the automation is set up right now, the tests are not going to run again. They would run again if I pushed a new change to this branch. But at the moment, as far as everything's concerned, this branch has been tested. The commits in this branch have been tested. We're good to go. And the same thing over here. So we have this test, or this ran the one existing test and the other new test. So let's say that we merge one of these. So if we merge that one, and it goes in. So right now we're fine. I mean, this code was kind of strange, but we're in a good state. So the repo was fine. Everything is safe now. However, now there's a problem, because and I'll just show you that. So let's say I pull this in here, just verify on my own. Unit tests. There's the 2 tests. They're fine. I've got the change that changes the default to 30. Everything is great, but now let's say that this other PR gets merged. So there's no conflicts because we're actually changing different lines, and the check that we ran passed. If we were to run that check now, we might have a different result. Not gonna go, that's a segue that I'm not gonna get into, but let's say we merge this now. So now things are not so great. So it didn't run the test again, that got merged. Let's pull the changes and see what happens if we run our tests. So now we're actually in a bad state because both of those changes got merged in, and they can't both pass because one is expecting the default to be 7 days, and the other is expecting the default to be 30. So if we look at the code that we ended up with, what we ended up with was the combination of both changes. So one change changed the line to change the default in the function signature, and the other one changed this other line, still a questionable decision. But anyways, they're both there because version control can't tell that we actually changed the functionality. It just knows which lines were changed. And then similarly, over in the tests, we have both tests. They're both present, and they can't both pass, and they don't both pass. So even though we had testing, automated testing on the PR, and even though we had coverage for the functionality that was being added in both cases, we still managed to get the repo into a bad state. So that was sort of an interesting revelation for me when I realized that kind of thing could happen. And so the question is, what do we do about it? So I'm going to show you a few different things you can do and discuss kind of the pros and cons of each. And I have a favorite, but the favorite is actually still, I can't demonstrate it because it is not a beta feature, it's a what do they call it? Whatever. I'm spoiling the results of this. It's not fully rolled out. You have to you have to ask GitHub to give you permission to use it. But I think I hope that they roll it out for everybody, and I'm assuming they will because I think it's a key piece of this whole thing that's missing. Okay, so let's do the terrible thing again and get rid of everything that I merged in here. I'm going to go back to when I added the test automation. Yay, everything's fine now. Back to okay, so let's see. So the first thing I'm going to show you is, so this one I'm going to show you, but it doesn't, I'm going to show you a scheduled action, but the timing is a little bit unreliable. So I want to get that in now just because I'm actually not sure if we'll ever see it run, because I'm going to ask it to run every 5 minutes, but it might be every 10 minutes or 9 minutes, or I think 5 is just the quickest that GitHub will even attempt to run this. But basically, I'm going to merge in a change where in our existing workflow, we're going to add a scheduled run of the test. And so I'll explain why this is one way of addressing the problem in a second. But first, let's actually get it in there so we can hopefully get to see it run. I don't know if we'll get to see it run at a time when the repo is in bad shape, though, so we're rolling the dice a little bit. But, okay, so we're adding this. I'll get into the details of this and why in 1 second. Let's just get it in there. It's going to run the test, though. I don't have branch protection on, so an immediate reaction is if I press that button fast enough, it'll merge. Let's look at the changes while that's running. So previously, we were running on pull request for the specific default pull request events. So now we're going to run on pull request, but then we're also going to schedule it using a cron tab to run every 5 minutes. So the reason that this is one way of addressing the problem is because it won't stop us from getting the repo into a bad state, but at least we would know it's in a bad state. So with what happened with those 2 PRs, we're not actually going to know when both sets of changes got in and we were in a broken state. Nobody knew it was broken. And so not only was it broken, but nobody knew it was broken. So we can at least address one of those 2 things. The only time somebody would find out it was broken is if they went to run the tests again, which maybe is because they opened a PR with a different change and then suddenly they have to deal with whatever happened here. But if you have periodic tests, or scheduled tests, so tests that run at a regular interval, then at the very least, those would, so let's say that we're probably not going to run them every 5 minutes. Let's say you ran them once an hour or something like that. Then a change like this goes in, at least by the next hour, there's going to be some kind of alert that something went wrong. So not the best because you want to be in a releasable state and you're not, but at least you would know that you're not in a releasable state. Some downsides of that, though, are that somebody has to be paying attention. So what will end up happening is, let's see, so I can show you some previous ones. So what will end up happening is that if you were to go here and look at these workflows, you would see that one failed. I think that if you're signed up for, I'm not 100% sure, but notifications for the repo, you would probably find out that it failed. I'm not sure that I don't think it would be sophisticated enough to go and track down the authors of the recent changes. and tell them that it failed. So in this kind of case, when you have something like this running, you often need to have some kind of like person who's responsible for paying attention, or some kind of rotation, like a rotation that's like a build captain rotation, or something like somebody who's responsible for watching the builds and then acting on them if there's a failure. That's kind of it's a downside because it's a time sink. It's not super rewarding to do. But I think there are a lot of advantages to having periodic tests like this. So in addition to potentially catching something that's fallen through the cracks of everything else, there's also things you run into like flaky tests, or tests that sometimes fail and sometimes pass. If you have periodic tests running, that can be a great way to reveal those instead of relying on whoever is unlucky enough to open a pull request and hit one to deal with it. So there's advantages to periodic tests. But anyways, that does not actually fix our problem. That just helps reveal that there is an issue. So I'm going to show you another way that you could mitigate this. So let's open these two pull requests again. So open the one that defaults it to 30. Open the one that defaults it to 7. 2, yeah. Okay, so we got pull requests open for both of these. So another way that we can mitigate this, which will stop us from getting the repo into a bad state, is that we can add a branch protection rule to our main branch that says that you can't merge until you're up to date with the latest changes. So let me show you. Let's say, okay, so this one's passed. So let's say we merge the default to 30. So again, at this point, we're still in a good state. Everything is fine. The problem now is that the tests pass over here for this default because they haven't pulled in the changes that we just merged. So what you can do is you can set a branch protection rule. So we're going to set our main repo, and for some reason you have to turn on status checks in order to get this to work. But so we're going to say for that check that we just added that was called test, we're going to be requiring that. Not 100% sure why these two pieces of functionality are linked together, but that is a question for GitHub, not for me. And we're going to, the important thing here is that we're going to check this requirement, require branches be up to date before merging. So that means that if there's any other changes that go in the meantime, you have to update the branch before you can merge it. So I can show you what that ends up doing. So that's, I think it's saved. It's saved, right? Yeah, saved. Okay. So now over here, what should happen is we should detect. Let's do a little refresh here. Yeah, okay. So now we can't actually merge this anymore. Not because anything is aware that the tests are going to fail, but just simply because it's out of date, because something went into the main branch that didn't come in here. And so now we have to update the branch. So if I did this, I think it would create a new commit in my branch that would pull in the changes from main, and then that change would trigger the test to run again, and then the test would fail, and then we would catch the problem. So that would stop us from getting into this bad state, and this will work. So the downside of this is it's not huge. It depends. It really depends on the size of the team that you're working with and how frequently they're updating the repo, because it's fine if there's just a few people, but if you imagine like 30 or more, or 20 or more developers, and they're all opening pull requests against the same repo, what it could end up, and they're all opening frequent pull requests, which hopefully you would be if you're trying to do continuous delivery, but that's another topic. What the situation you run into is every time somebody merges something, it's going to block the rest of the PRs, because every single PR is going to need to be updated before it can be merged. That's not a huge deal because they pretty much just have to either hit this button that'll do it for them automatically or pull the change in themselves. But if you think about how that looks when it's happening repeatedly throughout the day, I think that could get really frustrating and become a bit impractical. So I think for smaller teams, this is a great solution that will stop you from running into trouble. It's also a little bit, I think, less desirable for some open source projects when you have a lot of contributors, because again, anything that interrupts your contributor, especially if they're not a frequent contributor from getting their changes in, can be really frustrating. And so this is just one more thing that can kind of get in the way. That's another option. So let me turn that off for now. And then I've got two more options to show you.